Hello, aspiring student programmers. Today we're going to explore the fantastic world of Sequelize ORM, Object Relational Mapping, an essential tool for working with databases in Node.js. We'll journey through 10 core concepts, each increasing in complexity, from basic setup and CRUD operations to more advanced topics like associations, transactions, and complex queries. Sequelize not only simplifies database work, but also bridges the gap between object-oriented programming and relational databases. Understanding these concepts will empower you to create more efficient, scalable, and maintainable web applications. Now, let's dive into the code. Starting from the top, we first import Sequelize and establish a connection to our database. This involves specifying the database name, username, password, host, and the type of dialect we are using, in this case, MySQL. It's the foundation for any operation we'll perform using Sequelize. Next, we define a model using Sequelize define. Models in Sequelize represent tables in your database. Here, we've created a simple user model with name and age fields corresponding to columns in our database. The insert data function showcases how to insert a new record into the database using Sequelize. We use the create method on our user model, passing in an object that represents the new user. In find data, we demonstrate how to find a single record. We use the find one method and specify a search condition in the where clause. This returns the first record that matches the condition. Updating data is handled in the update data function. We use the update method on the user model, specifying what data to update and the condition for which records to update. The delete data function illustrates deleting records. We use the destroy method and provide a condition to determine which records to remove. Associations are critical for defining relationships between different models, tables. Here, we define a one-to-many relationship between user and a new post model, meaning a user can have many posts, but each post belongs to a single user. Fetch user with post demonstrates eager loading, a way to automatically load associated records. This is akin to performing a SQL join. We fetch users along with their posts in one go, avoiding separate queries for each user's posts. Transactions ensure data integrity by wrapping multiple operations in a single atomic process. In transaction example, we show how to create a user and a post within a transaction. If any operation fails, the transaction is rolled back, and no changes are made to the database. Lastly, complex queries shows how to perform complex queries using Sequelize's operators. We find all users over the age of 25 with a name that includes Doe. This illustrates how Sequelize queries translate to SQL logic, providing powerful tools for filtering and retrieving data. Through this exploration of Sequelize, we've covered fundamental to advanced topics, establishing connections, defining models, performing CRUD operations, handling associations, executing transactions, and constructing complex queries. These concepts are crucial for creating extensible, reusable, and efficient applications. Extensibility is evident in how Sequelize allows for model associations and complex queries, enabling your application to grow and accommodate new relationships and requirements. Reusability comes from defining models and operations that can be used across different parts of your application, streamlining your code base. Efficiency is seen in Sequelize's ability to manage database connections and operations, optimizing performance and resource utilization. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video to be helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding, keep exploring, and keep building amazing web applications.